Today's speaker is Conley Oster, the co-founder and chief operating officer of Raise Robotics, and we are thrilled to have him joining us today. Conley is a Penn State graduate with a background in structural engineering and extensive experience in project management and crane and rigging sales. His work focuses on bridging the gap between job site realities and emerging technologies, helping to make robotics practical and impactful in the field. And through Raise Robotics, Conley is helping to reshape how we think about labor, safety, and efficiency in construction, really making him an ideal speaker to start this series off, focused on innovation and the future of the industry. So please join me in welcoming Conley Oster.
Let us begin. Welcome to my talk. Thank you for coming, first of all. Before we get kicked off, I did want to ask the audience, how many students do we have in the audience, just by a show of hands? Okay. What about contractors? Do we have any contractors in the audience? Brace yourselves. All right, so I'm Conley Oster, the man pictured on the screen on the left. As Jen stated, I'm a civil engineering graduate, class of 2018. Admittedly, not a great student, but I do think I have a lot of lessons learned that can make everyone in the audience a better student if you're currently studying. While I was at school, I was involved with Formula SAE, which I would say is a little atypical for a civil engineer, but my passions really ran the gamut of all types of engineering. I didn't love one type of engineering. I love certain aspects of everything. And as you start looking ahead to your careers, and we'll talk about it a little bit later, it's really important that you spend time doing what you enjoy doing while you're still in school. So coming out of college, even though my degree was in structural engineering, went to work for Apple as a manufacturing engineer, lasted about 5 months and did not love it. Realized that, a company of stature is not the best place to make an impact. And as such, ended up going on Glassdoor, trying to find the highest paying job in my degree, which was in structural engineering. Ended up in the crane and rigging industry, doing sales, engineering, as well as project management. Did that until 2021, where I ended up founding Raise Robotics alongside my partner, who was a software engineer for the autonomous trucking division at Waymo. So I'm kind of the brawn of the company, he's the brains of the company. While I was at school, my favorite course was eDesign 497. This was the fundamentals of SolidWorks with Randall Bach. Loved that course, ended up paying dividends in my career and long term, ultimately gave me the ability to start designing and manufacturing hardware for a robotics company. And then it seems similar to a lot of Penn State stories, but on the very first day of my LEAP program, met my wife, and we now have a 19-month-old and are expecting our second child here in the next month. So before we dive in, just wanted to give a quick glance of what we're doing at Raise Robotics. Our mission is to build multi-purpose mobile robots for the construction industry. Really hoping to change kind of the paradigm in construction, deliver social impact while improving safety, efficiency, and quality on job sites. Been around almost 4 years now, which is crazy to think. And to date, we just wrapped up a seed fundraise. We've raised almost $12 million. Primary applications that we're deploying on job sites right now, as well as some factory settings, layout marking, inspections, drilling, and assembly tasks. We have won some awards along the way. I think our biggest win to date was the CEMEX Global Pitch Competition last year. And then as far as investors, we have both strategics, such as Hilti, as well as large institutionals, such as Zakua. And then our customers, a lot of self-performed general contractors, such as DPR Kojima, as well as specialty subcontractors in the facade industry, such as Harman, Staticus, J.R. Butler. And we're even licensing some of our software to some other autonomous robotics companies like State College's own, XHab 3D. So for today's agenda, I'm going to be talking about why the industry needs automation and why it needs it now. The current landscape for construction robotics, a deeper dive onto our company, and then for the students out there, how to position yourself adequately for a career in construction technology. Before I begin, just wanted a little bit of a disclaimer. Views and opinions expressed in this presentation are solely my own, do not represent those of my company, customers, or our investors. During this presentation, going to be primarily focused on just the commercial building market. Not going to be diving into industrials too much, no residential, just what I know and what we've done. So why construction needs automation? Let me ask the audience. Can someone just shout out a reason why now for automation?
Labor shortage.
Boom, okay. So there's a handful of, I would say, easy buckets for kind of explaining why automation is impactful now. And labor is definitely on the forefront of this need. I will say it's not something that's new. There has been a labor shortage. It's just been amplified by other issues on site as well. Looking at labor today, it accounts for 40% of your project overall cost. 94% of contractors surveyed this year said they can't find people. And right now we're seeing between 500,000 and 1 million unfilled positions, depending on which statistics you're pulling from. And coming from crane and rigging, this is definitely something that I felt firsthand. And it was a paradigm shift over COVID. I think COVID was really the forcing function for a lot of this widespread adoption of new technologies and people even giving a chance to new technologies and trying new technologies. Before COVID, I will say I always estimated my projects very aggressively. I wanted to win work, a lot of work, and as such, I knew that I needed a good team. I always had an A team or a B team that I could send out to specialty projects and be confident that I could meet both budget and schedule. And then COVID happened, and it was pretty much anyone in the crew that was considering a career change or considering retiring left within a matter of a year. And what ended up happening is those projects that I estimated pretty aggressively, we now weren't able to be choosy with the labor that I was staffing the projects. It became an issue where I was looking for warm bodies to fill these positions. I wasn't looking for qualified labor. I couldn't be picky, and as such, had some underperforming projects there for a little bit. But this, I think, as an industry, was really the forcing function where it was, originally, it's always been a challenging labor market, but it turned it from challenging into desperate for a lot of people. And it became a reactionary cannon for people to try new things to meet production output requirements. It's just labor, right? No, unfortunately not. There's also a production problem. This is kind of the second large cannon that everyone loves to talk about. And everyone loves to compare it against manufacturing. Construction is not manufacturing. 90% of construction projects are over budget. 35% of the time on site is unproductive time on site. Whether it be rework, admin, it's not adding value to what is actually being built. 72% of projects are delayed. And looking at continuous growth in the industry, it's always been stagnant. I mean, looking all the way back to the 60s, it's almost been 1% every single year. Comparing that to manufacturing, you're seeing manufacturing 4 to 6 times the output that you see in construction. I will say it's not always fair to weigh construction productivity against manufacturing because manufacturing did have forcing functions over the last 100 years. Militarization, global affairs, these are forcing functions for people to try new things in manufacturing because the production had to increase. And we haven't had the same government support in increasing production output within construction. But when you compare it against all other industries, it's a very similar story. Productivity has remained stagnant. It's actually declined in many instances. And this is measuring productivity as the real value of work put in place, divided by the hours worked on site. When I was putting the slide deck together, everyone likes to point out the fact that construction is not as productive as other industries. I was curious what industries construction was more productive, specifically in the last 30 years. And the trend that you'll notice is construction is more productive than labor-heavy industries or industries that do have significant regulations. This makes automation adoption in these industries very difficult. And I think if you look at hospitality, it's low-skill work that you're trying to offset with the usage of automation. Obviously, it's very challenging to get a very expensive robot flipping burgers to see a measurable ROI for small restaurant owners. We are still seeing, advancements in both hospitality and healthcare, but it's not as, I think, wide of an opportunity as construction. As the labor has continued to become more difficult to find, the price per head continues to go up. As such, the integration of automation and the, I would say, decrease in price point for automation makes this very viable to integrate cost-effective automation and see real ROIs compared to manual labor. And then digging into kind of the third and final, I would say, obvious bucket for why automation is needed. Safety is still a problem. I'm sure everyone's kind of seen how things have changed in the last 20 years in construction. There's a lot of regulation. There's a lot of safety precautions put in place. It has improved safety, but it hasn't solved the entire problem. And I think that's the unfortunate truth here. Construction's still the second most fatalities per industry, just lagging behind logging by a mere percentage point. It accounts for 20% of all industry fatalities. Looking in the last 2 years specifically, there's actually been an increase in non-fatal recordables on site. And I think one statistic that's becoming very top of mind for contractors today is the growing issue with mental health within the industry. It's a stigmatized industry. I think people don't necessarily always feel appreciated. They don't have a lot of the same benefits that other industry workers have. As such, you're 4 times more likely to see a construction worker committing suicide. Looking at 2022, there was over 6,000 construction worker suicides. And this also leads to, I think, an amalgamation of the safety statistics. Faults from leading edges are the #1 cause of fatalities within construction, but we don't know what that actual cause of the fatality was or if it was purposeful in nature. So this is something to keep an eye on. The fourth and final bucket that oftentimes gets overlooked is the change in risk ownership within the project delivery lifecycle. There's been a large shift of who owns the risk for delivering a project. There's a lot of general contractors out there that are very proud. They own the process. They don't own the means and methods to actually do the work. They manage the work in process. So as such, subcontractors on projects are owning most of the risk for project deliveries. And when that's compounded with the barriers to entry for subcontractors within the industry, it's never been more difficult to win work or just get on a project. There's a significant pre-construction effort that's required. And if you're not a complex subcontractor or have administration support, it's almost impossible to actually get on site. So that's all, most of the misery. I do want to talk about some of the positive trends that have been, forced out of where the industry is at and where it has been for the last couple of years. 80% of contractors today have said they've adopted construction technology in some way, shape, or form, whether it be hardware or software, in the office setting. Most ENR top 500 contractors have VDC teams. The statistic actually kind of surprised me. It's only 50%. But it's still trending in the right direction. Contractors are becoming actively involved as strategic investors and setting up corporate venture arms to help actually guide the products that are coming to market and make sure that they're going to be impactful in their own businesses. These are companies like Suffolk, Bouygues, Kojima, DPR, Obayashi, and Bechtel. And then an emerging trend that we're seeing right now that I'm truly excited about is contractors creating ecosystems to test and validate products. This has been largely lacking from the North American market. Even though we're the market lead for creating the startups, we're not the market lead for facilitating the growth of the startups or the adoption at scale of the startups. By not having physical space to test your products, it forces suppliers such as ourselves to test in live conditions. And the applications that us, as well as other construction robotics companies, are focused on are primarily critical path deliverables within your projects. So as the adopter of the technologies, it's extremely high risk to both parties, both the supplier and the contractor. And this is being mollified by the building of these testing facilities with replicated live conditions for suppliers. And then kind of jumping off on that investment topic, Investment in deep tech, and I think social impact deep tech, has been blossoming, especially in construction technology. Just in the first quarter of 2025, there's been over $1 billion put into construction tech investments. In that, 55% are focused on robotics and AI-powered solutions. And pulling a slide from Zakua, our investors' slide deck, don't sue us, please. You can see kind of the paradigm shift in their CVCs. So this is our investors that are being asked where they want their money to go. And it's spread over 2023, 2024, and 2025. And as you can see, unfortunately, there's been a large continuous downturn in focus on sustainability and a continuous uptick in interest for AI and robotic solutions. So as such, you're going to see a lot more solutions coming into the market since these are early stage investments in the pre-seed, friends and family, and seed stage. And then stepping back and just looking at kind of the startup ecosystem as a whole. How big is it? Are there going to be successes? The graphic on the right is information that's pulled from Crunchbase, who analyzes startups and investment and fundraising rounds. For every 10,000 pre-seed companies, you're going to see 1,000 seed stage companies, similar to ourselves. Of that, 1% get pushed through to a Series A, and from that, only 1% will reach unicorn status. This is when your company is valued at $1 billion plus. We actually just saw one of the first hard tech companies reach that $1 billion valuation, which was Gecko Robotics out of Pittsburgh. They're not primarily focused on the construction industry. They're focused on inspections. That's kind of cross industries. But what we're seeing in the market right now for hardware is you have to diversify not only within construction verticals, but outside of construction as well, and have broad applicability of your technologies. And there's been some other complementary trends that have come to market over the last couple of years. The biggest one that ultimately enabled us to become a company was the commoditization of sensors and compute. Advanced technology has never been cheaper, and this is largely due to advancements in autonomous vehicles, warehouse robotics, AMRs. Everything's coming down in price where it's actually cost effective now to the point where you can prototype, test, and build within a dorm room and then come out of college, enter your product into market. Additional kind of levers that have influenced the adoption have been the acceptance of AI. It can be a touchy subject, but largely the public recognizes the benefits and accepts AI solutions. The same goes for drones. Sorry about the redundancy on the first slide. And then looking at manufacturing and academia. So I mentioned, AMRs, vision systems are getting better. This is compounded by both bin picking in manufacturing facilities matched with academia. And collaborative robots have become mainstream in many manufacturing settings as well. So you're able to work around automation, which hasn't always been the case. Before you had to have very stringent safety and machine guarding, similar to a CNC machine. You're unable to actually collaborate with the robot, but now you are. And then looking at big tech. So this is one of our biggest benefits that we're seeing right now, specifically in the Silicon Valley market. There's been a large shift in the mindset of the top engineers at large tech companies. I think everyone collectively is looking for more social impact solutions of advanced technology. They don't necessarily want to just design a robot or a vision system that handles picking pharmaceuticals or moving a box from point A to point B. It's not having a large social impact. So as such, we're seeing a lot of these senior engineers actually starting their own companies within the space, receiving a lot of funding given their stature in the space and what they've done at companies like Amazon Robotics, Google, et cetera. As such, it's bringing the entire market up. There's more investment activity coming in. We're seeing more qualified candidates following that same position. And right now, it's still an employer's market. There's no shortage of qualified workers in this space. So it's actually made it very competitive for a startup like us to go up against, a FANG company, Facebook, Amazon, et cetera. So in summation of this slide, it's never been cheaper to build or hire for deep tech applications. What are the kind of primary challenges for a startup entering into the market? There's the obvious challenges. I think the first one, everyone thinks about. It's a dynamic environment, it's unstructured, things change, things aren't where they're supposed to be. How are you gonna deal with this? And 10 years, 20 years back, it wasn't possible to work around this. If your components, your installation location wasn't in the right spot, there's no way to counteract that. But this is also where kind of the advancements in vision, haptics, sensors, et cetera, and sensor fusion enable robots to see, feel, perceive, and react to the environment that they're around. Very similar to how a Tesla would operate. Another challenge, looking at it from the lens of a roboticist, there's no existing building training data. When we started our company, the only way to get data to train synthetic learning models or our algorithms was by deploying robots on site. There's no web store to just go download real renderings or information from construction sites. It's still a large problem. Limited existing cycle time data. This is on the contractor side. Oftentimes, the applications of robotics go on kind of the micro scale. If we're completing layout marking, I would expect that the contractor understands how many floors are you able to do each week. What we found so far is when we uncover new applications, oftentimes the contractor doesn't have a very good scope on how long things actually take in the field, adding ambiguity to a solutions provider trying to accelerate into this market. Today, I will say most contractors lack fundamental digitization. We are a reactionary market by nature, and I'll talk about that on the next slide. VDC teams and companies hold limited power in organizational change. Just because you're tied into a VDC team or an innovation team as a supplier does not guarantee you're going to be scaled across the entire organization. A lot of the times, these are very siloed teams that do not represent the larger organizational decisions. And it's a show me industry. I think a lot of tech is a tell me industry, or it's something I can sell over the phone to someone by explaining the benefits. Construction is not. It's a show me industry. You have to get your hands on it. If people want to use it, they're going to want to see it live. They're going to want to test it. They're going to want to put it through the paces and make sure it can actually add value. As I had alluded to previously, there's really never been a low-risk way to show contractors. If you're showing someone a demo in an office, it holds no water. It's not going to replicate conditions on site, the dust, the sun, the noise, vibrations, etc. The only way to really get someone sold on your product is by deploying live on site, which again is risky to both parties. And then the kind of adoption expectations. This has become very clear since we started the company. The assumption most people think is that if you can land in one of these buckets, you're going to have a solution that someone would buy. If you're able to do it cheaper, if you're able to do it faster, safer, or higher quality, people assume this is sufficient for adoption. What we've realized is that you have to excel in all four of these categories. You have to be easy to integrate. You have to be cheaper than the traditional labor. You cannot sacrifice your quality. You have to be more productive. So it's a very challenging sales cycle when compared against traditional means and methods. And this is kind of our thesis comparing our market versus other markets. Looking at China, Singapore, Saudi Arabia, these are proactive markets. Looking at reactive markets, it's USA, Canada, the UK. Proactive markets have government mandates for usage after you get past a certain number of square feet, top-down incentives to contractors deploying technology in these markets, strategic planning commissions that are government-sponsored just for the adoption and scaling of technologies. There's already been these ecosystems. When we look at Obayashi, they have a staff of over 150 roboticists. When you look at a company like Kojima, there's over 100 people on just the VDC team. These are things that have been established for decades now that are fundamental to how their business actually gets work done. As such, it's very easy for them to seek, adopt, and scale new technologies. And this is where I think the US and reactive markets come up a little bit short. We're a reactionary market. It's forced adoption given the labor shortage, production rates, et cetera. We don't have structured adoption motions. We're just starting to see this with general contractor innovation teams, a structured adoption motion, how to actually weigh the benefits these technologies bring to the table. Some contractors lack a good understanding of their existing processes. I will say, looking at a reactive markets such as the US, it's the most solutions providers in a market, but if we don't have the fundamentals in digitization for contractors, there's no way to adopt and scale this effectively. There's no way to achieve that unicorn status and scale. Oftentimes, this leads to reactive transactional relationships. I'll talk about it on the next slide. Some startups get stuck in pilot purgatory. What we're getting stuck in right now is project purgatory. The sales motion for equipment and labor has always been per project. It's impossible for most people to get contractors to step back and sign annualized agreements when they don't have foresights into when their next projects are going to be started, or if there's any market uncertainty, things slip, things get canceled. I think after the tariffs went in place this year was a very good example of how this happens. So, in summation of this slide, proactive markets build self-sustaining ecosystem of innovation, while reactive markets are left playing catch-up, relying on technology to solve immediate problems with limited to no flexibility. That said, we're doing a good job now of building this ecosystem. We're just a little bit behind. I just don't want people to think everything is perfect in construction technology. So talking about kind of the typical sales motion or adoption cycle that construction robotics startups have to go to. Similar to being in crane and rigging sales. Get a pitch to contractors, get in front of them face to face, tell them why your product's important, but obviously, as I had mentioned, you do have to show them why it's important so that they can decide if they want to use it. For technology specifically, it's extremely important to find an internal champion within your organization that can help carry your message to other members and help run the numbers on the ROI calculations for the organization as well. Before you test on site, you have to establish success metrics. What we're doing now is establishing these success KPIs, and then once these are achieved, it'll immediately turn into a larger scale adoption across the organization. Otherwise, you can get stuck in a loop right here between establishing KPIs, piloting, reviewing results. After this has been accepted, the KPIs have been met, this is where, again, you scale with the organization. And what we've seen time and time again from other companies in the space and even ourselves is getting stuck in this doom loop, pilot purgatory. And this is largely in part to regional fragmentation or company fragmentation. Again, your project champion being on the innovation or VDC team, not necessarily having the power to force organizational change. Having unrealistic success metrics that maybe you can't meet. One example of this that we just ran into yesterday, actually, we're getting ready for a TI project drilling dowel pockets in a very large retrofit. When we asked our project lead what the expectations were on cycle time, we were told between 30 and 50 holes per day. We worked with this contractor for 2 weeks before this and took cycle time measurements of their crews on site. In 2 weeks, they completed 200 holes total. But the metrics for adoption were now a quarter of that within an hour. So it's important that you do, as the startup, also do your diligence in the cycle time estimations. You come up with something that's reasonable at the end of the day. Okay. Then talking about the current robotics landscape. So we're in a very, very exciting time for construction robotics right now. We're starting to see the commercialization of a lot of robotics companies, and they don't look like research projects. They look like real equipment, and they're being used as such. And these are companies like Dusty. I think they're the market lead. It's very easy to say that. The market lead for adoption, the market lead for sales motion as well. And then companies like Built Robotics and heavy equipment, or Hilti JBot for overhead drilling. But with kind of where things are at, I think it's very important to have perspective. The best way that I think to look at this is looking at the Gartner hype cycle. This has been tailored to just robotics in 2025. And on the vertical axis, this is kind of the visibility, or more so the hype around the solution. And then on our linear axis on the bottom, we have this over time. So there's 5 primary stages to the hype cycle. You have your innovation trigger, which is, this is a product that's needed to be brought to market. Peak of inflated expectations. This is where there's way too much hype around certain solutions. Trough of disillusionment. This is where people are going to say, this is never going to work. There's no way forward. Slope of enlightenment. This is where there's a little bit better reception to adopting these technologies again. And then finally, when it's just a normal product in the market, this is the plateau of productivity. If we look at this right now, I do have to say, with as much hype has been going into the space, largely in fact that we are seeing more of these, I would say, executive teams leaving large tech companies. They're raising, $100 million rounds with no product. There's definitely too much hype in the space right now. But with that said, there's still products that are adding value to customers. I think in reality, with the items I mentioned before regarding kind of that digital foundation for a lot of contractors, we're still a little ways away from that plateau of productivity. And I would say it's probably in that 5 to 10 year range right now. So digging in a little bit to the on-site mobile robot taxonomy. What's out there? What are kind of the classes? I think if you look at Built World's classes, I don't necessarily agree with their taxonomy. This is kind of how we see it in the market. So you have single-purpose robots. These are robots like Dusty, rugged layout robots, finishing robots, painting robots, just doing one targeted single application. The benefits of this, obviously it's exceptional at a singular task. It's been designed just for that task. And I would say this is similar to a specialized tool at the end of the day. The cons, because it's only doing a singular task, if you are the contractor adopting this technology, let's say you're buying a layout robot, and your layout for a data center is going to take 10 days, 2 weeks. Unless you have 26 data centers, there's no way to get 100% utilization out of this equipment because it is single purpose in nature. As such, we see a lot of the single-purpose robots get shelved, and this is a dynamic that people are struggling with right now, is how to optimize for uptime, just focusing on a singular task. What ends up happening is that the customers don't want to adopt on an annualized basis or purchase outright. We see that these suppliers then have to be in charge with the distribution, oversight, and logistics of the robots, since the customers won't adopt at a larger scale. So it's harder to scale, limited market channels since it is very specialized, but again, exceptional at doing that task. And then I'm gonna jump over to general purpose. So these are Boston Dynamics Spot, the Unitree legged robots. These are productized pieces of equipment. This is something you can go on Amazon and purchase. They offer a lot of upside for flexible applications. What we do see is that the people oftentimes adopting these don't realize how much investment is required into these robots to actually get something meaningful in return out of them. As such, this is why you see a lot of spots dancing at trade shows. They're not on site scanning things, they're dancing because they didn't realize an extra 100 grand was required to get the LiDAR and to get any outputs out of it. And then falling in between them, this is kind of the new class that we fall into, is multi-purpose robots. Large market applicability within vertical construction and other construction verticals, Limited downtime given the larger applicability to different applications. They're more scalable, and I'll say they're more like a piece of equipment at the end of the day, not necessarily a specialized tool. The users can use them as they see fit. They're not going to be stuck to a singular application. The cons, there's more moving parts. Inherently, they're going to be more difficult to service. It's a more opaque ROI calculation since you then have to run it on each application that they service. It's not going to be doing something continuously. The form factor might not be the best fit for all aspects of each application that it does surface. There might be some edge cases that it can't. I did want to talk about an emerging trend that we're seeing in the market. Is anyone familiar with Bright Dream robotics? No, you should be. So this is a trend that we're seeing in proactive markets like China and Singapore right now. quickly cloning single-use robots that exist in the United States and Israel, scaling them with the support of the government, and as such, you're seeing companies like Bright Dream, which have completed over 350 projects, have 45 different single-use robots, they're government-funded and sponsored, and the usage is mandated. So they have a very quick path forward being in this proactive market. So this is something to keep an eye on. One of the, I would say, downsides to companies like Bright Dream Robotics, it's very easy to clone and scale these solutions. It's not easy to clone and scale a high accuracy solution. So that is kind of the technical moat that we're seeing in the marketplace between a proactive and reactive market right now. Okay, did want to do a little role play. You're a general contractor looking to minimize project delivery risk on your upcoming project. Would you choose independent electrical, mechanical, and plumbing contractors, or one qualified contractor that could handle all three scopes of work? Asking the audience, what are the risks associated with having more subcontractors?
Whose fault is it if something goes wrong?
Liability is definitely one of them. Any other answers? Conflict in scheduling? Yes, exactly. So this is a similar kind of thought process that is going to be evolving with robotics in the future. Thinking 5-10 years in the future, does it make sense to have 100 robots doing 100 things on site? It's hard enough to manage subcontractors on a project. It's going to be impossible to manage robots that are all programmed in different languages, and there's no cohesive, universal oversight of these robots acting on the same project. This is why we're really leaning into that multi-purpose robot platform. It limits risk to those adopting it in the future. And then taking a very broad stroke here, if you're studying construction robots, please don't be scared with this oversimplification. I've broken it down into five primary buckets. Pretty much every construction robot works the exact same. You upload your project assets. These are the inputs to the robot, your BIM, your CAD, your PDFs. You run a digital takeoff on your inputs. This is ultimately what establishes the machine code and the action plan for the work to be completed. When Dusty analyzes their layouts, it's creating the path of travel for the Dusty robot on site. When we upload a facade plan view, it's establishing where we're installing brackets or where we're drilling. And then the third step, that is the most important step, is localizing the robot to your work environment. And this can be done a couple different ways. The most, I would say, accurate and the most popular right now is using a total station. This can be just any robotic total station, as long as it has continuous tracking on board for reflectors. You can also use metallurgical equipment, so just like a total station, but 4 times more expensive and micron level accuracy. Or you can err on kind of the looser tolerance side. Use visual markers or use SLAM. So you can act like a Roomba on site to map your job site, or you can use visual computer vision to actually recognize April tags on the walls. The issue with any visual or SLAM is that you're limited to pretty much plus or minus a centimeter at the absolute best as far as your localization accuracy. Why this is important? This is what is putting the robot within the building's coordinate system. If this gets messed up, doesn't matter how good the robot is. It's not going to work. It'll print, but it will not print in the right spot. And then you execute the work command. This is just telling the machine to go to work. For pretty much every solution on the market right now, there's still a human in the loop. There's not many things that are fully autonomous outside of earth-moving equipment. So this is a problem that we run into, Dusty runs into, Rugged runs into, Canvas runs into. Any construction robotics company is dealing with this problem right now. And it hasn't been a problem before because many subcontractors are just starting to adopt total station usage. So control points have been around for a while. This is ultimately kind of the skeleton of your project. It's your origin for where all work is supposed to be datumed off of to have a cohesive project delivery and dimensionally accurate delivery of multiple trades on site. It's the basis for all work completed on a job site. And you can see in the viewport on the left, this is what our upload looks like in the robot's UI. So the reference to control points is extremely important. This is ultimately, the tie back to the job site. So any work completed is completed accurately. What we're seeing in the market right now, contractual obligations, this varies between plus or minus 1/16 to 3/8 of an inch. This is what our customers, who are the facade subcontractors, request of the general contractors to provide on their projects. What we see most of the time, we're getting between plus or minus 3/8 of an inch all the way up to 3/4 of an inch. It's a constant problem with job site deployments where control is unable to be established accurately. A lot of the time it comes down to who they're putting on this job and kind of the misunderstanding of how important it is. This is oftentimes your first 2 years on site. You're getting put with a total station to establish building control. It's not complex to learn, it's very complex to perfect, and it's becoming growingly important as more automation is adopted into the workflows. If control is not established correctly, you'll end up with a transform of the CAD components that have been uploaded, ultimately leading to errors in the work being completed on site. If this foundation is not established, the physical foundation and the digital foundation are not established, again, you're going to end up with incorrect information and incorrect work, ultimately rework because of automation on site. So again, the lack of digital fundamentals lead to a lot of issues. One thing that we notice outside of control being an issue is that we're receiving incorrect digital inputs. This comes by the way of CAD and BIM. This is directly from a previous project. So on this drawing, this is the overlay of a glazing contractor and a precaster. All of these are supposed to be 0, 0. These should be perfectly overlaid on the CAD outputs. Almost an inch error, 3/4 inch error. What we ended up finding is the general contractor submitted 2 different drawing sets to each contractor. They fabricated components to 2 separate, completely different drawings. As such, we're laying out with the robot. We notice that the precaster's coming over, and we're like, that looks weird. We should be dead nuts. We're at a 30-second in the lab. We don't understand what the problem is. Dig into the drawings, huge issues with the drawing sets. Same goes, same project. This is our control points. We get on site, instantly flag control issues, escalate it to general contractor on site. They send out their surveyor and field engineering team to lay out 15 points. They say, we'll make sure the job site's covered. You'll have all the points you need. 15 points, we get 2 good points that are within the allowable tolerances. Kind of outside of this, it's obviously, looking at it from the robotics perspective, a very challenging problem space. This is also what makes it very exciting for the suppliers and technologists that are in this space. You're applying manufacturing level accuracy to a dynamic environment. You have robots working outside in weather. You have new obstacles that pop up on every single job site, every day, every hour. Your path of travel gets blocked. Ultimately, really tests your communication with others on site. And then you can still run into issues with both user error, incorrect inputs, incorrect drawings, or robot error. Condition was not modeled in our rendering for the robot. We forgot to add the reflector to the end of our robot. We path planned without the reflector, ran into a column and broke the reflector. These are all things that happen during this kind of innovation, development, deployment lifecycle. All right, moving on. Our company, Raise Robotics. Again, what we're building, multi-purpose collaborative mobile robots for on-site construction and industrial applications. As far as our applications that we're focused on right now, it's primarily leading edge applications. That's where we're servicing layout marking, any geometries, text, emojis. We can print them on the slab while working behind the edge guarding. So this is leading edge, walls, ceilings, up to 13 feet. We are partnering with a mobile equipment lift provider that will allow us to apply all of our technologies into scissor lifts and boom lifts here in the next 6 months. In addition to layout marking, working in drilling, scanning, and laser profiling, as well as assembly of facade systems. This is just another quick video from some previous project work. We have both single arm and dual arm robots. On the back of the robots, there is essentially a toolbox. It's very similar to a CNC machine. and how it's able to actually swap between the tools. It's all pneumatic actuation. The entire robot is IP65 rated, so it does stay outside for the duration of projects. When it gets shipped to a project, it gets shipped on a flatbed, untarped, similar to any construction equipment. You can see here computer vision outputs, so applying a lot of that same AV technology for human and obstacle recognition into component recognition that allows us to actually interact with multi-step assemblies and ultimately install these brackets faster than a crew can do it. One of the major benefits with the application of robotics within construction is the ability to collect data passively. This is a massive benefit. Robots are data magnets. You don't need a QC QA team to come back and actually check work. The robot can complete that while the work is in progress, unlocking further benefits in production rates. And then here we got our drill. So we've co-developed this alongside Hilti. We're scaling up this line of business significantly in the next couple of months. Our market sectors, new build commercial construction, again, focused on self-perform general contractors as well as facade specialty subcontractors. TIs, we're kicking off our first industrial manufacturing applications. And this is for an EPF manufacturer who does tanks, vessels, and skids, marking where things need to be cut, where they need to be welded, how they need to be welded, using the laser profiler to also inspect the components coming in to give them a right of refusal for $100,000, $200,000 components. We're also scaling automation enablement. So this is actually a photo of XHab 3D. They're a partner company with us. We've licensed our localization software to them, ultimately enabling a mobile robot to be a mobile robot and print large form structures by being able to maintain that last point to date them off of. So how did we end up with kind of our current applications? When we started the company, we looked at what are the critical path deliverables for commercial construction. Plumbing, electrical, walls, facades, superstructure, and substructure. And this is a graphic that we've carried with us since 2019. It's been on every single investor deck that we've had. And it's breaking down the percentage of overall commercial construction project cost into the specific items. And you'll notice that facades, structure, concrete or steel, and MEP encapsulate a majority of the overall project cost. And at the same time, the majority of their overall cost is labor. So this is the perfect kind of mesh point for the enablement and usage of automation. These are high impact items with a lot of labor and a very high dollar value. What makes us us at the end of the day? Our positioning, so our localization stack, we're able to achieve plus or minus 1/16 in field conditions on a very large machine, and we will be achieving that same tolerance even at height. And this comes down to how our robots are calibrated and how we're able to overcome a very dynamic environment. Our vision and motion planning. This is what ultimately allows us to work off very minimal information. A lot of robotics providers now require BIM inputs. The reality is many contractors don't have BIM inputs. They have 2D plans that are in the field in a job box. That's all our robot needs to get working because we're able to fill in those knowledge gaps with the live inputs from our vision and motion planning softwares. And then haptics, so force sensing and feedback, being able to complete work blindly. For our bracket installation use case, we're able to train a model to actually install a bracket without seeing anything from the computer vision inputs. It's very similar to changing your oil in the blind. We're able to feel when those bolts were slotted within the anchor channel to actually complete an installation. Even furthermore, building out robustness in the software capabilities and ensuring that worst case scenario vision system goes down, we're not losing a bracket off the side of a building. And again, this leads to increased, I'd say, ease of integration for our contract partners. We're not reinventing the wheel with inputs required to the robots. That's a massive undertaking and a huge issue for a lot of other construction robotics companies that require BIM integration and BIM inputs. They end up having to upsell BIM services on top of the robot rentals, really pricing themselves out of the market. We're designed for the field, again, deliver on a flatbed, fit in the smallest hoist. We've just shaved off 300 pounds from the robot with this scissor lift integration. So it will look a little bit different, but it'll be using the same back end, same tooling. Then one recent case study from St. Jude's Children's Hospital completed the layout for a 14-story hospital building at plus or minus 1/16 of an inch accuracy, shaved off 5 weeks of the schedule, 20% cost savings compared to the manual-only methods. No time spent beyond the edge guarding, so 100% committal to ensuring safety of today's workers. No high lines needed to be set up. And for this project, it was a lump sum operated rental. I will say there is a lot of pressure on suppliers like ourselves to provide the staff to either oversee, set up, or use the projects. Many customers want just a drag and drop adoption. They don't want to facilitate the upskilling of their internal teams to adopt. Okay, so right now we've completed over 4,000 hours in operation. I think one thing that is very different for us, we're partnered with the unions. Our approach has always been improving safety, improving the longevity of careers within construction, while also attracting the next generation of construction workers. Kicked off our first Train the Trainer series about 2 weeks ago down in Philadelphia. Trained 12 union employees, gave them a test, and all 12 passed, which is a testament to, I think, the ease of use for our robots. We did have some passionate conversations during that meeting as well. And it really showed kind of, I think, where a lot of tradespeople are at in viewing automation. Immediately, I mean, it was a high-tension training for the first 2-3 hours, and you could feel something was bubbling in the room. And someone raised their hand, they're like, this is taking my job. And they were like, if you're doing multiple applications, it's taking more of our jobs. And it turned into a town hall debate between two sides of the room. You had union people that view it as a tool or a piece of equipment. This is something that improves our livelihood, improves accuracy, ultimately enables more work to be won from contractors using the technology, versus the people that were just scared of technology. It's a very real fear that's in the market now. By the end of the conversation, it divulged to a point where we were debating what is the purpose of being a human at the end of the day. So there's still speculation. The reason I brought that up, by the end of the class, everyone said they saw the robot as a tool, and it is something they would use, which is a testament to, again, usability, but also you got to demystify these things. And if you look at the video here, the first thing that we did when we got the robot in the classroom, they were like, take off the side panels. We want to see what's inside. And so we did. We took it apart. Everyone was able to touch everything on the robot. And when you see components that you recognize, oh, there's an onboard compressor. That's a pretty cool compressor. There are items that are kind of shared experiences that enable a more demystified release of technology and adoption of technology. So where we're going in the future and where we're going right now. So again, we are expanding our tooling and applications. We're applying our scanning. So this is our as-built data collection surface profiler, as well as the layout marking tool to industrial applications in manufacturing. So marking where welds need to be, where cuts need to happen. Going to be developing a fusion cutter as well to actually cut through the skins, plasma cutter, to cut through the skins and actually complete the work at hand as well. And again, we are partnering with 2 large MUP OEMs to white label our robots on their platforms. In addition, continue to scale our software licensing. So this is our localization stack, our motion planning, path planning, etc. Okay. And switching gears a little bit, just advice for students. I think looking at my career to date in review, I'm doing exactly what I wanted to do. It's really a combination of all the things I love. You have the statics aspect, the dynamics aspect, there's parts of structures, there's a lot of e-design that's thrown in, a lot of business development. You get to wear a ton of hats. It's really everything that I hoped for in a career and I didn't find to date. So I'm hoping to enable some more people to get into construction technology. Asking the students, this is something I struggled with. Does anyone here feel anxious about their career or about their major choice at the moment? Thank you. That's normal. My advice, wholeheartedly, just put time into what you're passionate about and the right opportunities will come. We do receive a ton of qualified robotics candidates, but it's oftentimes not the academia that moves the needle for us moving forward in the hiring process. It's personal projects a lot of the time. Personal projects that are done on things that they really enjoy. We've hired mechatronics engineers that didn't have professional degrees in mechatronics, but they exemplified what it meant to build a mechatronics system. They did it for a fun project. The same goes with kind of your undergraduate or graduate course load. Again, I did not get a degree in mechanical engineering. I was not accepted into mechanical engineering. I was a bad student. I got into structural engineering and then was able to complement the course load in my undergrad with electives that were in my areas of passion. And these were always mechanical design, e-design, business development, entrepreneurship. And as such, it did get me where I wanted to go. Another piece of advice, don't chase logos. I really, really, really wanted to prove it to myself that I could work at Apple. And I ended up working at Apple. But it wasn't what I thought it was going to be, working at Apple. The photo on the left, my parents took on my first day of work. The photo on the right is my first day in Foxconn 10 days later. This was half of my life, was just in Foxconn. Very dreary, very depressing, and just very different. So again, my advice is don't chase the name, the company name you want to put on your LinkedIn page for social validation from others. It is cool, it is fun. I don't think it's worth it at all. Like my entire career very well could have been me working on the placement and adhesion of 2 magnets inside of an iPad keyboard. Low impact. And with these larger corporations of great stature, you're also just limited in what you can work on. Again, I mean, this is a prime example. 2 magnets. I didn't even get all of the magnets. That was someone else's job. And in these large companies, there's very bureaucratic structure, and there's a way for things to get done. There's really not much room for innovation in the large corporations. So keep that in mind as you're kind of structuring yourself for a career. Everyone wants to make an impact. Everyone wants to feel as though they mean something to their team. Large company, at least in my experience, not where you get that. So stepping back, you're looking at a career in construction technology. What is my advice? How do you break in? This is, aside from passion projects, most important aspect for any position we hire, whether it be robotics engineers that have PhDs or material scientists, software guys. If you have field experience, you're going way up in our hiring list because you understand the process on job sites. If you're designing in a siloed environment, you don't understand what it means to actually integrate something into the existing workflow. If you're a contractor adopting and it doesn't fit into your workflow, you're not going to use it. And this is also a great way to pick up additional applications and really suss out your thesis on specific applications. This is why I'm very thankful for kind of my wonky career choices after Apple of going into crane and rigging. Got to see up to 12 projects every single day. A lot of problem solving on the fly, and you get to see every aspect within construction. I'm definitely not recommending everyone go be in a specialty subcontractor because it is a different lifestyle, but go intern, go co-op, go talk to a general contractor about how you can improve their workflows and how you can integrate yourselves into their company, whether it be for free or as an internship co-op, et cetera. And it's going to be equally important as you get into building that company as well. When we had started the company, our initial focus was on applying 6-off robot arms to complete the installation of the facade panels themselves. When we got on site and started talking to people that are actually completing the installations, it became glaringly obvious. The pain point wasn't in the installation. This is oftentimes where there's a lot of pride for their job. They call themselves cowboys because you hang over the side of the building, you get to install these couple 1,000-pound panels. But the installation itself wasn't the project delivery issue. It was the installation of the brackets that actually dictated the alignment of the panels. The same goes for their layout markings along the building edge. These are what ultimately tell you where to put the panel. If we didn't go on site, we wouldn't have uncovered the root cause of our initial problems in the field. Ultimately, this is why we started with the facade bracket installation use case. And then expanding upon getting in the field again, that's, I think, the most important part. Build a diverse engineering background, as mentioned earlier. take electives in areas that you're truly passionate about, even if they're completely different than what you're focused on right now. Be curious, ask questions. You're gonna be talking to a lot of contractors getting into the field. There's no dumb question, quite honestly. There's just questions that other people are thinking and have not asked, and that is the reality. If you sit in a contractor meeting, you get 15, 20 people, no one really asks questions, but when you ask a question, it becomes very obvious that everyone was thinking the same thing. Again, personal projects, be a good communicator, specifically if you're gonna be in robotics. There's so much cross-team collaboration between software, hardware, customer teams, contract teams, operations. You have to be an efficient communicator between teams being able to deliver the same message in different ways. And finally, be an empathetic listener. No one's going to explicitly tell you they have a problem in the field. It's up to you to really pick up on those social cues in conversation. Thank you.
All right, so we're going to continue the conversation. I hope you've had a chance to get to know people at your table a little bit while you got some food. But let's have our question and answer period now with Conley Oster. So again, at your table, if you do have a question that's come up, scan the Slido code and you can submit that question and we'll add it to the queue. We have a couple of questions already here, so I'll go ahead and read them to you so you don't have to squint, Conley. So one of the questions that we have is, what was your biggest hurdle in your entrepreneurial pathway?
I think our biggest hurdle starting the company was actually insurance compliance, making sure that we had the proper coverage in place. Being a construction robotics company, I think we were probably the first construction robotics company to go to a lot of the brokers. It's hard to establish, what labor class you're fitting into if you're acting as a contractor, manufacturer, developer, and surveyor at the same time. I'd say that's probably the most difficult aspect of starting the company, and I do know that's a shared struggle with a lot of other construction robotics companies.
All right. The next one is, does your company own patents for hardware or software?
Yes. We've patented process patents on the installation of the components, and on the localization stack that we're using as well as the end effector integrations.
All right, the next question is mine. I admit it, it's mine. But you mentioned reactive markets, and what would you say are the top 3 legal or regulatory barriers that you see preventing construction robotics in those reactive markets, like the US?
Legal or regulatory? I mean, I do think like the pre-construction requirements to getting on a job site are difficult. I do feel like contractors shouldn't be punished for trying things out on job sites. There needs to be a little bit more cohesion between the contractors, owners, and insurance brokers as well. I think what else? There's also certain city jurisdictions that just have very different equipment deployment regulations. Like looking at getting a tower crane in New York City, it's drastically different than a tower crane in Baltimore. So each city kind of has its own nuances, and the same goes for the labor force and unions in those cities as well.
So along those same lines, is there something in particular that you think we should be doing to help Pennsylvania lead in innovation in construction robotics? Are there things that you can identify?
Yeah, it's creating that ecosystem. And I do think, there's contractors here today that are doing just that. But you need to have cohesive communications between general contractors, subcontractors, owner-developers, insurance, academia, startups. You really need a seat at the table for everyone, and it de-risks it for everyone. Having testing facilities or replicating on-site conditions in a low-risk environment, everyone benefits from it. And Barton is doing just that, so testament to them.
Great. We have a follow-up question on the patent one. How hard is the patent process for you, and how much money can it cost?
It's like between 5 and 15. If you get a provisional, it's around 5 to like 7,500. Like fully kitted, you're looking at like 15 grand per patent. Depends on which patent attorney that you're working with at the end of the day. No shade, can't say we love ours, but they get it done. It's surprisingly easy, quite honestly.
Okay, so I'm encouraging you to all submit your questions. I'll keep reading through a couple of them. Do you have? Yeah, you can raise your hand. You don't have to use the Slido.
Hi, thank you so much for the very comprehensive presentation. So I actually had a question about the slide that you showed where you position your robot as a multi-purpose robot. I also noticed there are other companies that are trying to integrate hardware onto construction equipment, like Caterpillar, and then you just have a kit. So how do you classify those companies? And
I would say autonomous equipment.
so it's not under any of those.
I'm just, with this presentation, just focused on mobile robot applications on construction sites. Didn't want to open that can of worms, because that can go on for a while in autonomous equipment. And also off-site prefabrication automation. Those are two kind of major classes that I did not review.
Thank you.
Mm-hmm.
I think you should explain the SkyDeck program at Berkeley. How,
We'll
I mean,
make
from
you.
a-
We'll
from
make
the-
you repeat that.
From the standpoint of a college, how Berkeley incentivizes startups, which is actually, it reflects well on the college.
Yeah.
Why, I mean, I don't know if people are familiar with that program and the money that's available.
For context, this is my dad.
Good question, Dad.
Yeah, so the only reason we're a company is because of Berkeley SkyDeck. This is essentially a venture arm of UC Berkeley. There's tens of thousands of applicants every single year. You have to have a tie back to the university, a founder that went to school there or a graduate degree. You pitch to them, and as such, they give you a pretty significant chunk of change. So right now it's up to $210,000 to start your company. They provide you mentorship, advisory support, access to all software and hardware and resources the university has. As such, you give them a tiny bit of equity. But everyone that was in our cohort 13, which now is 4 years ago at this point, they're all still around. So it's a pretty significant umbrella that gets cast with each of those cohorts. And ultimately, it enables the startups to scale effectively and answer questions that only industry experts are going to know. And those are all compensated advisors that work with that program as well. I do know that Penn State is also establishing something very similar. So it's a very good program.
We've had a couple of questions come in on the Slido. You said you don't rely on BIM data for your robots, but do you use 4D simulation in advance to showcase the work you're going to perform on the projects?
We do. We do model training and a lot of synthetic data training as well. There's always a simulation aspect of it, especially since we are multi-purpose. We get a lot of new applications of existing tooling. Like for that industrial application, the only reason that we were comfortable taking it on is we ran the robot through an entire simulation, completing the work, and then got a contract signed and deployed.
Okay, another question that came in, how can Penn State be a leader in better preparing the workforce for a changing construction landscape?
Yes. I think emphasizing the importance of VDC, BIM, and surveying, quite honestly. Those are the enablers for all automation and technology, specifically looking at kind of the civil degrees as well as architectural. You need to understand why that's important. That does enable a lot to be built on top of it. I think also just cross-functional engineering classes, they don't have to be super detailed, but covering, what can you do with robotics? The only way that I've learned is by doing it. How do computer vision systems work? Where do things fail? What are the issues with hardware design for very robust environmental conditions? So I think just more crossover classes between engineering degrees.
Any other questions? Yeah.
Go easy.
So I was in industry, so I have more industrial questions. So, what's your business model? in general. And I think when you have when you're like trying to scale, I imagine that you're in that stage right now. I think supporting staff will be really key on deploying robot and making sure things can work. What are your strategies around that?
Yeah, so our business model, we're keeping it simple, keeping it digestible, and the exact same as renting other equipment on site. We do offer outright purchases. We offer annual enterprise agreements, but the majority of our sales come by the way of bare rentals or operated rentals on a per project basis. It's the exact same way that you're going to adopt other equipment or cranes, rigging operations as well. And then the second part of the question, as far as our strategy and scaling strategy, I think everyone feels a very acute pain right now in scaling. I mean, this is every startup, regardless of how far along they are. And it comes down to the fact that there's really limited distribution channels to amplify your distribution. You look at equipment distributors and they're still a little risk adverse. Even though they are investing in the space, they're not actively adopting and scaling these solutions. So the only way that we've seen companies be able to achieve distribution outside of their own channels has been general contractors adopting the solutions and then also upselling those to other subcontractors on the project or mandating usage across their projects. So that part it's challenging. It'll get there. But what we're doing right now, this is also kind of a key aspect of our partnership with IUPAT. We train all the union employees on the usage and oversight of the robots, but at the same time, they serve as distribution channels for us. We know exactly where the project work's going to be. We know who needs to get trained, and then we can deliver robots locally from these training district council centers.
Nice. Thank you.
Other questions?
Well, thank you for such a wonderful seminar. And I think you touched on some of the potential directions going for the future. And I'm just wondering, from a kind of an industry perspective, do you feel technologies are already there for large market adoption? Or you think actually there's still a couple breakthroughs you would wish for that can really help the whole adoption process?
Right now, the technology works. That's been a change in the last 2 years, I'll say. There has been a switch that's been flipped. Before, there was always, little edge cases that could throw off the robot from working, or maybe it wasn't that reliable, but it's been commoditized now, and it's a commercially viable product. And that's, looking at companies like Dusty Robotics, or Rugged Robotics, Canvas, et cetera. It's still that scaling challenge where unless there's more emphasis put into the inputs that are going to the robots, it's going to be hard to achieve that scale, because if we print your layout and it's slightly incorrect, but it turns out it's the drawings, no one in the field recognizes that. That comes down to, the robot is incorrect. So we still need to put more emphasis on the fundamental digitization and establishing cleaner controls on site for all contractors. Otherwise, there's really nothing you can do as far as automation adoption, and there's no advancements that would be able to mitigate those inputs.
Other questions?
So thanks for your great presentation. So I have a question about because at the beginning when you choose to develop construction robots, I see your robots have the construction task, for example, the layout, the drilling, and also the fastening. So what's the reason for you to choose these tasks for the robot, and why do you think these kind of tasks can be integrated on one robot? Thank you.
Why these tasks? This is largely customer driven. If it was up to us, I can't say that we would have chosen all the applications that we've taken on. It's really just been field input on where their pain points are, what they don't enjoy doing, and where they need help. And it's been consistent with quality critical and highly repetitive or highly risky tasks. Those are kind of the three buckets that we look for when we're analyzing an application. And the other aspect of that is it technically feasible? That's a huge part in determining to move forward with an application or not. There are plenty of requests that we receive that just are not technically feasible from a robotics perspective. And then I think the second part of your question was why one robot for these tasks. So this circles back to kind of the change in philosophy that we're going to see. This is also, I would say, a gamble on our side. We can have the robots working as a single task robot, but thinking about the management of robots in the future is really the driver for us to be multi-purpose in nature. It also allows you to go, like looking at our facade bracket installation use case, if we just had one tool, we could not service that scope of work. Oftentimes, a single-use robot is just a fraction of the scope of work. It's not encapsulating or servicing the entire scope of work. That's the same with a lot of the drilling robots that you see on the marketplace today. If you deploy a drilling robot to drill overhead hangars, it should be able to install the hanger. Otherwise, you're still exposing yourself to risk getting on a ladder to install the hanger after the robot's drilled the hole. So it allows us to go end-to-end with the solutions and limit risk to the adopter's communication, schedule, budget, etc.
Other questions?
In terms of risk, you mentioned about control points being messed up, and it was hard to maneuver around that. And was there any case that you have encountered liability issues with, like your work not being accurate due to that control point, or was that due to your robot? Like, did you have any difficult moments?
Of course.
And I want to hear about that. If you, as much as you can, of course.
Yes, I mean, kind of that example that I had showed, it pretty much, it hit every possible issue on inputs, where control was bad, we had to disprove control, we had to get control rectified. You have to convince the contractor that it's wrong and it needs to be fixed. You also have to educate the contractor on what the implications are to bad control to your product. So this isn't the same implication as someone that is doing manual survey work on site. I think what happens a lot of the time and gets brushed under the rug, there's field fixes a lot in layout and surveying. And these are, kind of buried risks that contractors don't even know they've assumed. And if you talk to the surveyor people, oh yeah, we cheated the points over a quarter inch, a half inch, we lined up, we don't have any issues. Those are all things that got brushed under the rug previously, but are now very top of mind. Yeah, I mean, what we try to do is to make and educate the customers on how the robots work. So we'll start with an independent accuracy test when we get on site. We drop off the robot and we show, we're gonna print a line 5 feet long. Take out your tape measure, measure the 5 feet. You can show that it's 5 feet. We'll do a complex geometry, a triangle, a circle, show that it's perfectly cylindrical, perfectly round, have them measure it, and then you tie into building control. And this, you can measure building control before you tie into it, but once you tie into it, you can recreate the exact same geometries. Oftentimes you'll notice, there's a little bit of a transform that's happened in this point, and it's because your control points are a little bit off. So we really try to take it step by step, show that the accuracy of the system is accurate, independent of the control network. Once we start doing the actual layout, if we do notice that there are significant issues with control, we can establish our own primary control and secondary control. At the same time, that's assuming a lot of risk to us completing kind of those judgment calls. So we prefer to just have it rectified by the general contractor supplying the points. Mm-hmm.
Okay, we have another question here in the back.
Your current answer just answered my question, but I was thinking that improper or incorrect drawings are the bottleneck currently. So are you working on something that is autonomous and that can circumvent these issues before we need for any human interference?
So yeah, right now we can automate the entire takeoff to generate the machine code and work points for the robots. We learned our lesson on fixing other people's broken drawings previously. This is, similar to establishing our own control network. We can do it. Should we do it? No, we should not. We should not be accepting that liability. Because if something's wrong with it at the end of the day, we're the one that gets sued. So yeah, again, we have fixed other people's drawings. What we prefer is that they fix them and resubmit them to us. And then with the takeoff, it's entirely automated already. But a lot of the times you're not going to notice drawing issues until you have multiple contractors that are supposed to be working off shared points.
Great. Well, this has been really fantastic. I hope you've enjoyed the Lunch and Learn. I do want to thank Conley Oster again for being such a wonderful speaker. Thank you for your time today and sharing your insights.